What are biomarker discoveries in chronic fatigue? Imagine if we could find biological clues that tell us exactly what's happening inside someone with chronic fatigue syndrome. That's what recent biomarker discoveries aim to do. These are measurable signs in the body that reflected the underlying issues of the disease, helping us understand and diagnose it more accurately. Researchers have made exciting progress by studying blood, stool, and other biological samples to find these clues. One of the most promising areas involves circulating cell-free RNA, or cfRNA. These are tiny fragments of genetic material floating freely in the blood. Scientists have identified specific patterns of cfRNA in people with chronic fatigue syndrome. These patterns suggest immune system problems and ongoing inflammation. Using advanced computer techniques, or machine learning, researchers have created models that can detect these cfRNA signatures with high accuracy. This means we could develop simple blood tests to help diagnose the condition more reliably in the future. Another key discovery relates to the gut microbiome, which is the community of bacteria living in our digestive system. Studies using artificial intelligence have shown that in chronic fatigue syndrome, the balance of these bacteria is disrupted. This imbalance affects the immune system and metabolism, the body's chemical processes. Researchers have found lower levels of beneficial fatty acids like butyrate and changes in other metabolites such as tryptophan and benzoate. These biomarkers can distinguish people with chronic fatigue from healthy individuals about 90% of the time. This highlights how important gut health may be in the disease process. Large-scale molecular studies have also identified hundreds of blood biomarkers that differ significantly between those with chronic fatigue syndrome and healthy people. These markers are linked directly to the disease, not just to the symptoms of reduced activity. This supports the idea that chronic fatigue is rooted in real biological changes, countering old beliefs that it was mainly psychological. Research into immune system function has revealed abnormalities in immune cells. For example, some immune cells called mate cells show altered activity, which connects gut health to immune responses. These immune signatures point to a persistent state of inflammation, which is a hallmark of the condition. Understanding these immune changes could lead to targeted therapies that help modulate the immune response. The discovery of these biomarkers opens up many possibilities. For diagnosis, it could lead to reliable laboratory tests that confirm chronic fatigue syndrome, which is currently diagnosed mainly through symptom checklists. For treatment, understanding the biological disruptions suggests new approaches. Since the microbiome and metabolites are dynamic, interventions like diet changes or targeted therapies might help restore balance and improve symptoms. Interestingly, these biomarker findings are also relevant to long COVID, a condition with many overlapping symptoms and biological features. This connection could speed up research and help develop treatments for both conditions, offering hope to many affected individuals. Overall, these biomarker discoveries mark a major step forward. They help validate chronic fatigue syndrome as a real biological illness and pave the way for better diagnosis and personalized treatments. As research continues, understanding the complex interactions between immune function, metabolism, and gut health will be key to unlocking more effective ways to support those living with this challenging condition. Always remember to consult healthcare professionals for personalized advice, as individual experiences with chronic fatigue can vary widely.